students, how are you all? So now we are again there along with the next part of the topic, that is metals and non-metals. Students, we were doing chapter metals and non-metals, in which we have done physical properties of the metals and non-metals, and we have started doing the chemical properties of metals and non-metal, in which we have just discussed very important chemical properties of metals as well as non-metals. That is the reaction of them with the oxygen, the reaction of metals and non-metals with water. Similarly, reaction of metals and non-metals with acids, right? Now students, we are going to discuss today the fourth type of reaction, that is the reaction of the metals and non-metals with the bases, right? So first of all, we are just going to discuss about the reaction of the metals with the bases. Generally, metals, they do not react with the bases, right? All the metals, may be the strong metals, they may be the other metals are there, mostly they do not react with the bases except the amphoteric oxides. Students, there are some few metals which are coming in the category of the amphoteric oxides. Now first of all, let me explain you people what are called the amphoteric oxides. The metals like the aluminium, zinc, lead, etc., they are coming in the category of the amphoteric oxides, which react with the acids as well as bases to form the salt and hydrogen, right? Normally we have discussed about it, the metals, they react with the acids to make the salt as well as hydrogen, they will be produced as the products. But some metals like the aluminium, which I have told you people, amphoteric, which react with the strong alkalis only, not all kind of alkalis. First of all, two conditions they should be there for the amphoteric oxides also. First condition should be the alkalis might be very strong, like the sodium hydroxide as well as the potassium hydroxide. These both are the alkalis which are so strong in nature that they are very corrosive to the skin even, right? So, and secondly, the alkalis, they should be freshly prepared. Means we do not do the experiments when they are already prepared there in the lab. Means few small particles of the sodium hydroxide, when they will be dissolved in water, the freshly prepared sodium hydroxide solution, this will be prepared, which is very hot to touch. Because freshly prepared solution, this is the reaction is highly exothermic in nature, right? So means the freshly prepared sodium hydroxide, so when it will be reacting with the amphoteric oxide like the aluminium, zinc and lead, they make their respective salts, which are very complicated, very complex salts, right? The salts will be not so easy as the sodium chloride, sodium sulfate, potassium chloride, potassium sulfate, magnesium sulfate, etc. These salts, whenever they will be prepared, they are very complex and also they produce the hydrogen gas. Like in the case of the acids, they immediately form the hydrogen gas which is released. This will immediately burn with the pop sound. But here in this case, when the metals, they react with the bases, the hydrogen produced will not immediately produces the pop sound. It will take some time to just do the reaction, right? So now students, as the equations are very clear, when aluminium, I have told you people that amphoteric comes when aluminium, this reacts with water to make their respective oxides, right? So when aluminium in the presence of the strong alkali, that is sodium hydroxide and water, the reaction occurs, and during the reaction the product formed will be called sodium aluminate, that is NaAlO2 is called sodium aluminate, where the balancing we have done of the reaction along with the hydrogen. When the burning splinter will be brought near to the mouth of the test tube in which the reaction have occurred, after some time it will burn with a pop sound. Similarly, zinc also reacts with the sodium hydroxide and water to make the this sodium zincate, right? Sodium aluminate. Then the sodium zincate will be formed along with the hydrogen gas. Similarly, the same kind of reaction will be there with the lead, right? Means when the lead, this reacts with the sodium hydroxide and water, it makes the sodium plumbate, because lead जो है, this the name of the lead is also called plumbum, right? So that's why the product form will be plumbate, right? So sodium zincate as well as hydrogen gas, it will be produced there. Right, students? So this was the reaction of the metals with the bases as such. Non-metals, they also react with the bases, but the reaction will be so complicated that we are not including them in our course. We have only of them. It is the displacement reaction, right? So it is very, very interesting reaction. We have done the activity series. If you remember the activity series, it was very, very important to understand all the chemical reactions, right? For the metals as well as the non-metals, especially for the metals as such. So now what are displacement reaction? The displacement reactions are the reaction in which more reactive metal takes the place of less reactive metal in its salt solution is called displacement reaction. What to sum up is the more reactive metal. For example, we have taken the solution of the copper sulfate. Copper sulfate is a salt solution. Blue color solution is formed when magnesium, small amount of magnesium ribbon, a piece of the magnesium ribbon, it will be put in the copper sulfate. What will happen? Magnesium will take the place of the copper in the copper sulfate solution to make magnesium sulfate, and copper will be produced. Right? Similarly, there are some more. Aluminium in the reactivity series, it is coming after the magnesium. Students, sodium, potassium we are not going to take because very dangerous to do the reactions. So that's why this is starting with the magnesium. Now, aluminium, when it will be dissolved in the copper sulfate solution, it will form aluminium sulfate. Al2SO4 thrice is a formula for the aluminium sulfate. Means aluminium have taken the place of the copper in the copper sulfate solution, and residue will be the copper. What to sum up is how we can understand about that the reaction have occurred. This will change the color of the solution. And secondly, you have seen the magnesium ribbon color. It is silvery color almost, right? And when we will see, we will take out the strip from the solution, it will be reddish brown. Student, reddish brown is the color of the copper. Similarly, aluminium, similarly have the silvery color, right? So when aluminium this dot, it will be put in the copper sulfate solution. First of all, the solution will become colorless, right? And secondly, the strip which we have put, it will be having the reddish brown color, that is of the copper color. Now third will be iron. Iron nail, it is having the gray color. We usually used to do the experiments in the lab. We used to show the experiments in the lab to the students. This is very, very interesting. It is also there, the part of the course in 9th and 10th standard also. So let us discuss it with, when a gray color nail, it is put in the copper sulfate solution, iron will take the place of the copper in the copper sulfate, and the solution will be iron sulfate and copper will be formed, right? How we can come to know about the reaction have occurred? Initially, the color of the solution was blue color. A very beautiful blue color will be there. And after the reaction, the color of the solution is changed to slight greenish. Light greenish color will be there. The reason is there, the ferrous sulfate, that is FeSO4, have the green color in nature, right? And the strip will be, means the gray color, it will be the nail, it seems to be rusted. Actually, it is not rusted. This is the color of the copper, because copper color is reddish brown, right? So, as students, just remember it. It is very important to note it down. The reverse of it is not possible. What to sum up is, when a less reactive metal is put in the solution of the more reactive metal, no reaction will occur. For example, in the magnesium sulfate solution, if we put copper, then no reaction will be there. Reverse of this will be there if the copper is put in the ferrous sulfate or the iron sulfate solution. Again, the no reaction will be there, right? Now, students, about the non-metals, displacement reaction, they also occur in the non-metals, but in the non-metals, the reaction will be according to the groups, right? In the periodic table, the groups are the vertical lines in which the metals of the similar valency they are kept, right? The metals, non-metals which are present at the top of in the group, we can say they are more reactive than the non-metals which are kept at the bottom of the same like we might give the example of the halogens. Mostly the displacement reaction occurs with the halogens. Halogens are the non-metals with having the valence electron 7 in the outermost shell, and similarly valency -1, right? So according to the group, chlorine is more reactive than the bromine, right? Similarly, chlorine is more reactive than the iodine. So in the potassium bromide, when chlorine is put, so it makes potassium chloride and bromine will be left behind. Similarly, sodium iodide, when chlorine is put in the sodium iodide, so it will make sodium chloride and iodine will be produced, right? So this is of the all type of reactions. Now in my next lecture, I'll explain you the activity which is there explained in your book in detail about the taking the metals as well as their salt solutions. As such, this will make you more clear about the displacement reaction. Thank you so much.